Hi everyone, let's talk about today's LeetCode daily challenge. Today it's about a randomized set. So it's combining a set and it's adding a new operation which is GetRandom. So insert and remove are standard operations of a set, but GetRandom is not very standard. And so we have a new class, new data structure that can support GetRandom. But the point is that all of them should happen in O of 1. So the average runtime of each operation, insert, remove, and GetRandom should be O1. So for insert and remove, we know how to do that. If you have a hash table, you can have the insert and remove to be O of 1 on average, but GetRandom is not going to be O of 1. You should do some iteration over your table and find a random number, which is on average O of n. So how do we do that? Let's for a second, let's forget about insert and remove. Let's see how we can do the GetRandom. Let's say you have a list of, for example, 5 numbers like 6, 9, 2, 7, and 20, whatever. And you want to pick one of them randomly. If they are stored in an array, what you will do is that 0, 1, 2, 3, and 4, these are the indexes. What you will do is that you will generate a list you will generate an index randomly, and you will access the array at that position, and you will return that. As simple as that. So the get random part can be supported with having a list of the numbers that are in the set. So at any point in time, you will have two data structures to support these two. You will have a hash table for insert and remove, and you will have an array to support GetRandom. But these two should be somehow related to each other. Let's see how we can do that. So for this, we can have, to do this, we should see how we implement insert and how we implement remove. Let's go and see how we want to implement remove, because this is probably the harder one. For remove, let's say we have the same, let's say we have this list, and now we want to remove 2. So remove 2 is called, but we don't know where. I will call this the items list, items array. Remove 2, so we call our hash table. This is our table. And we ask our table, hey, do you have a 2? And it says, yeah, I have a 2. So we know there is a 2 somewhere, but we don't know where that is in our list. So maybe we can have a hash map and save the index of 2 in that hash map. Oh, okay. So it's going to be 2. In this case, the index is actually 2. So it's going to be 2 and 2. Let me change this to 20. So the value is 20. Okay, so this is going to be 20 and 2. and 2. So what this means is that our table, our hash map in this case, knows that there is a 20 and keeps track of the index of that value in our items array, items list. And why do we need that? Because we need to remove it from both of them. We need to remove 20 from the table, and we need to remove 20 from the list in order to access the second index directly, we need to save the index. So that's why we decided to have a hash map, which saves the value and its corresponding index in the items. So how do we remove it from the list? One way is to get rid of this and shift everyone to the left. This is again O of n, which is not good on average. It's O of n, but a more elegant way of doing that, because we don't have to move every item to the left. We can just move the last item to the left. So the revised version, the updated version of items should be like this: 6, 9. Actually, this is 20. Let me change that to 30 just for this example. This should be 30. You cannot have the same number twice. So 30. Okay. And 7. So what we did is we moved the last item in our list. So this is 0, 1, 2, 3. So we moved 30 from the end of the list to where we just removed one item. We should also update this. So we remove this as well. We should also update the index of 30 in our table. So index of 30 used to be 4. So we update that and say, hey, 30 is not there anymore. 30 is in the second cell of these items. That's it. So this is how we can support remove. All of these operations are O of 1, like swapping the last item with this item that we are removing is O of 1. Removing an item from the hash map is O of 1. So in general, all of them are O of 1, and we didn't do the shift. So all of them are O of 1. What about add? Let's see how we can support insert or add, whatever. So let's say we have a list. So this is 0, 1, 2, 3. The numbers are 5, 10, 7, 20. And our hash table, our hash map says, hey, 5 index is 0. 10 index is 1. 7's index is 2. And 20's index is 3. And now we want to insert, let me choose another color. Now we want to insert 50. So what we do is that we add 50 at the end of this list. We say, hey, this is 50. The index is 4. And we go in our hash map and say, hey, 50 was added. And now the index is 4. This seems to be working. We just add the item to the end of the list, and we also update its index in our hash map. And as for the GetRandom is the one that we solved first, actually. So we have the list. We just generate a random index from 0 to 4, and we access this. We return the value, the corresponding value. That's it. So let's go ahead and see how we can implement this. So we need two data structures here. One is a list, an array of size maximum. So the size is 2. This is the maximum number of inserts that can happen. So this is 2 times 100,000. So I'm going to keep a maximum. So const. So this is the maximum number, maximum length. So I'm going to keep a list. That's it. This is my array. I'm going to keep a hash map from int to int. I'm going to call it table. And I also need to know how many items have been put here. So I will keep an index, last index. I can also work with the size of the hash map, but I prefer to keep it separately for a better code. So int last index, and then I'm gonna initialize that to 0. Okay, so let's go ahead and implement each one. So for insert, if let's go and see insert, returns an item val inserts into the set if not present. Return true if the item was not present. Return false otherwise. So if the item is already, I'm gonna call this value. So if table.contains value, I'm gonna return false because I already have it. Okay, this is what we should do, and otherwise I'm gonna insert it. So I'm gonna say items of last index equals value, and then I'm gonna save this index in the table. So table of value is gonna become last index. So now I know if I ever want to know where is value located in items, I'm gonna ask table, and table is gonna tell me, hey, it's in last index. Okay, I'm gonna increment last index, and then I'm gonna return true because I was able to actually insert this value into our hash map. For remove, if it doesn't contain, so if not table.contains, I will return false. That means, hey, I cannot remove this. This doesn't exist. Otherwise, we should do something. Let's go and see how we can actually do it. Let me have an example here. Yeah, this is not good. This is better. Okay, 5, 9, 20, 2, 6, 8, and 4. Okay, so let's say we want to remove 20. I'm going to call this value. So value is going to be 20. Index is going to be 0, 1, 2, 3, 4, 5, 6. So I'm going to call this value an index. So index is going to be 2. The one at the end, I'm going to call this other value. So I'm going to call this other value. It's going to be 4. And other index. Index is going to be 6. So what should happen is, which ones are important here? This index is important, and other value is important because other value is going to go there and sit here. So after we are done here, it's not going to be 20, it's going to be 4. Okay, so let's write the code here, and then I'm going to type it there. So we know value, we know index is 2. So index is table. Table of value. This is the index. So if we are given the value, we can find the index with this table of value. Other value other index is last index. index -1, and other value is item of other index. Okay, if we define these for variables, it's going to be easy. So now we are going to update items of index. So items of index becomes the other value. So other value. Remember, so this index 2 is going to become 4. This is other value. And now we should update the table. So table of other value is 4. Is going to become index. And index being, again, 2 here. So if you need pause and think about these statements and see why they are correct. And after we are done with updating the items and table, we should remove value from our hash table. So that's going to be table dot erase value. And we should also decrease the size of the items. So we should just decrease last index minus. So we are just gonna decrease that. So that's it. Let's go and write this. So this is going to be value. So I need an index. So int index becomes table of value. Table of value. Int other index becomes last index -1. And int other value becomes items of other index. Now we should update the items. So items of index becomes other value. And now we should update the table. Table of other value becomes index. Then we decrease the last index. And we remove value actually from the table. Table.erase value. And at the end, we return true. Because we were able to remove value, we return true. So now we should do the GetRandom. So for GetRandom, we should have some random seed. And now we can just generate a random index and return that item from the list. Okay, that's about it. Let's run and see. Unordered map. Okay. Okay, let's submit. Okay, good. Let me know if you have any questions. Ask me in the comments. Thank you.